In today's video, we'll be talking about resistance. No, not that kind of resistance. We're talking about electrical resistance. What's up everyone, I'm Joseph and welcome to STEM in Focus. If you're new to the channel, please consider subscribing and hit the bell for notifications. To give you a general idea of what resistance is, let's take a quick look at a rubber hose connected to a water pump. Now, how fast it will take to fill a tank will depend on the pump pressure and the diameter of the cross-section of our rubber hose. Assuming we keep the pump pressure the same, a hose with a smaller diameter would take longer to fill the tank than a hose with a much larger diameter. The pump pressure and water flowing through the pipe are analogous to a voltage source and current, respectively. How easy water flows through the pump is referred to its resistance. Another simple way to understand resistance is using what I call the obstacle course analogy. Consider an inclined piece of cardboard randomly populated with push pins. If we roll 10 balls from the top side, some of the balls will fall directly on the opposite side while others will be blocked by the pins and may or may not fall. This analogy takes us to the atomic level of how resistance works. When the current is flowing, some electrons collide with the atoms of the wire, as I already mentioned in my previous video. The atoms in this analogy are the push pins. The higher the number of push pins or collisions, the higher the resistance. Depending on the atomic structure, different materials can be classified as conductors or insulators. Based on the previous analogy, a conductor will have fewer collisions than an insulator and is usually preferred to be used in wires. Another major difference between the conductors and insulators is the number of mobile electrons present. A good conductor like copper has a lot of mobile electrons, whereas paper, for example, has little to no mobile electrons. Both materials do have some resistance. This is what we call resistivity. This is realized in the expression R is equal to rho times L all over A, where L is the length of the material, A is the area of the cross-section, and rho is its resistivity. For example, for the same length and cross-section of copper and iron, the resistance will vary. Copper has a resistivity of 1.6 times 10 to the power minus 8 ohm meter. Assuming a wire of cross-sectional area of 5 mm square and length 10 meters, the resistance of the wire using the equation is given below. Similarly, for the same size of iron with a resistivity of 9.71 times 10 to the power minus 8, the resistance is also shown below, which is much higher as we expected. I hope that gave you a general understanding of what resistance is. If you found this video helpful, please consider clicking the like button and subscribe if you haven't already. Thank you for watching, and I'll see you in the next.